Okay.
Okay, you might need to pull up the slides on this one. It might be a little bit hard to see from the back. I'll reload the agenda. If you can't see the slides, they should be there on the web page, right? Yeah. So this is basically some fun with GNU-plot, looking at some data that most of you, I'm guessing, probably do not have. Most of us look at the traffic flows and statistics on interfaces, but you probably also run DNS, but you're probably not looking at that data. And I think it's actually kind of interesting to look at, and I know there's some issues some of you have actually looking at it, but even looking at something that may be seemingly not interesting turns out, in my opinion, actually to be somewhat interesting. So what you're looking at here, and what the graph will be similar on all the pages, are on the x-axis is a source port used by a client querier to a DNS server. And on the y-axis is the number of times that source port was actually used. So while there's a lot of clustering, it looks like there's overlap. There's only actually one point per coordinate. Okay, so what you're looking at on this page is a recursive server that's both authoritative for zones within an institution that's responsible for, as well as being recursive generally for domains outside the institution. So it's an open recursive server also, so clients outside of the institution use this, and I know that's bad. But in any case, so what you see is I'll point to, if this works, on your left, the screen up above, you'll see there's like a saxophone kind of pattern here, and it kind of goes down and to the right. What that is indicating is starting at about 1024 is clients using that port, and they become less popular as they go to the right. And so clients, Windows, in this case, that's what that cluster represents, tend to start using source ports at 1024. Actually, 1025 is usually the most popular. And then you see a complete fall off because Windows kind of wraps at 5000 and starts over again. And you see a little bit of a similar pattern way over on the right. That's where some Unix systems start. And then there's kind of a big gap in the middle. And then you see below 1024, there's a lot of white space. So looking at this, there's an obvious pattern. It's not a big cluster all over the place. And so some of the really interesting patterns that I found that weren't totally obvious was if you look at this point, I think it's right there. Okay, it's one of the high ones just to the left. That is port 137. Guess what that is? That's Windows stuff. And pretty much all of that is like Windows name lookups that are all bogus. If you look up towards the right, you see this point up here. That's port 5353, which you may think that some people are hard coding their servers to use that as a source port, but no, that actually turns out to be this multicast DNS stuff, which I'm not really sure what it is, but Macs use it, and you see that all over the place. Those are also all bogus as far as I can tell. And then you see a few other points here and there that are outliers, and some of those are interesting when you start digging into the data. It might be hosts that are misconfigured, or it may be something that's infected with some kind of bot that's querying for a name over and over again and not getting resolution on that name. Okay, so this is one institution server. I have 3 others. This is another institution. The graphs are very similar across all institutions. And I'm told by someone who's done this sort of analysis on traffic flows, the graphs are similar, although I'd like to check for myself because I'm not sure that I believe that in all cases. Here's another one. This is a large ISP. Again, there's some stronger clustering there in that middle valley, but the graphs are, again, still similar. You see the pattern with port 53 is obviously real high. That's up on the top up here, but you see 137 again, and 53, 53 also. And finally, another institution, again, very similar. And here is, if you take out all the external queryers for one of those graphs, here's what the graph looks like. It doesn't change too much, but you'll notice that there's a lot of white space now below 1024. And so what that ends up telling you is all those points that were there before were actually appear to be from machines behind NAT PAT boxes that were actually ended up using those low-numbered ports. Okay, and you also see some other things that kind of stick out, and so you might wonder, under that kind of saxophone picture, what's that point right there? Why isn't that one really used? And so when you dig into it, you find out it's port 1900, which is the plug-and-play port, which most Windows machines have enabled, so they can't actually use that port. So you find that that's one that doesn't bubble up on the graph. Going the reverse direction, here's what just external queryers look like. Again, very similar. In this case, you do see some additional outliers that might be interesting that you might look at. And here's if you were just to look at the pointer queries for all internal recursive as well as authoritative, inside and outside. You don't see the elbow shape on that 1024 to 5000, which I guess is kind of interesting. You do see the 5353 stand out right there. Okay. That's that multicast DNF stuff. That's all pointer queries. And that's a lot. And that's all bogus as far as I can tell. Here's MX only queries. And interestingly, to me, this looks like the Quad A stuff is relatively clean. There's not a lot of outliers here and there a little bit, but not that much. Okay. Now, a lot of these are probably bogus queries anyways, but nonetheless. Here's these are all 24 hours, by the way. Here's a picture of a Windows machine that was really doing pretty much nothing else but trying to contact an IRC server. And there's really only 3 points. There's one way on the left over here, there's one up here, and then there's one down there, and that's only like 1 or 2 queries. So what this was doing, the first point on the left, it was querying over and over for a name, and then something happened, like some automatic virus software that wasn't working started up, and then it actually changed ports and went to that other one and queried from that source port over and over again. I don't quite understand how that actually worked, but I thought that was kind of interesting. I don't know if that's indicative to how bots on Windows hosts work generally, but I thought I'd point that out. Here's a Unix machine that was infected with a bot. This one actually just behaved differently. And this is probably what you would expect. You would expect to see the port ranges pretty equally used. So if you were just to do analysis on this looking for bots, that might not actually work because that might actually look normal. If you see the ones above, that's probably just retransmissions, not getting an answer for a query. And then finally, this is just another plot of a Unix server that does a whole bunch of stuff from SSH to web server to mail and other things. And so remember again that even though this looks like a solid line all the way across, if you actually blow this up, there's actually holes in that. And so these actually fill in port numbers in between there somewhere. Okay. So I guess the next step in doing this sort of analysis is just by looking at source ports. That's kind of interesting. What other things in DNS can you look at to get even more interesting information? There's a lot more to look at than source port. There's not only the question, but the answer that you get back and things about the answer like the TTL and the IP address or IP addresses that you might get back. So for the 10-minute lightning talk, I thought this was enough to start with. So that's all I have.
All right, thank you.
Okay.